So, in the previous class, we have seen the concept of relational algebra, right? So, basically, relational algebra contains a set of operations, and these operations are going to perform on the relation. It is going to produce a new relation, right? This is what we know the meaning of relational algebra, right? So, if you observe, the concept is similar as sets in mathematics. Okay, meaning that whatever the result that is produced by the relational algebra, it is always going to produce unique data. It won't contains any duplicate data. That is the meaning of set, right? Set contains only unique data, non-duplicate data. Okay, fine. We have observed various kind of operations. Something like select is one kind of operation is there, product is there, rename is there, cross product, union, and some kind of extended operations like intersection, join. Inner things are there, division, or something like set difference. These are the various kind of operations we have gone through, right? So basically, so the problem with the cross product or Cartesian product is when you are going to perform cross product on two relations R1 and R2, you are going to get multiple columns, and that multiple columns also having meaningless data. So to overcome this drawback, we are going for join operation. Basically, every join operation will comes under theta join. Theta join meaning that if you are trying to combine two columns C1 and C2, if we can able to apply various kind of theta operations like less than operation are there, greater than operation are there, not equal to operation are there, or equal to operation, whatever maybe you can do, right? Meaning that while trying to combine tables of two tables, you are going to have some kind of criteria required to make the table result should be meaningful. So to make the resultant table data should be meaningful, you have to use some kind of common criteria. That criteria can be any kind of theta join, right? If this theta join can be equal to operator, then I can call it as a equijoin. Equijoin, right? In equijoin, for example, I am trying to combine two tables R1 and R2, and the attributes A1 and C1. If I am going to compare like equal to operator, meaning that when the left side of the table A1 having one value and the right side of the table having C1 contains one value, if both are matched, then the resultant table contains the respective row. That is the meaning of equijoin, right? What about the natural join? There are two tables R1 and R1 R2. You need to specify any kind of conditions. By default, if you are going to mention that it is a kind of a theta join, it should be a join. Theta join. So this is theta join, or I can call it as equijoin. This is what I can call as natural join because I have an operator called star operator, right? When you are going to use star operator, by default it is going to consider two common columns. Two common columns. Assuming that here it contains the A1 is one kind of a column, C1 is one kind of a column. Basically, these two would be same. Then the compiler will consider when both are common columns, it is going to apply the operation between those two. What kind of operation is going to apply? Equal to operation, right? So something like R1 which is equivalent to R1 theta join of A1 equal to A2 of R2. Both are same, right? But in theta join you are going to specifically mention the attributes also with condition equal to operator, whereas in natural join you are not going to mention because it will directly consider as if there are two common columns are there, it is going to simply apply equal to operator. That is the meaning of natural join. Natural join, right? And why they are calling it as extended operations? These three are because these three operations I can able to derive it from the all the basic kind of operations. That's why I can call it as extended operations, or I can call it as the basic operations as complete set operations. This is what we have seen in the previous class, and also we have gone through various kind of queries, right? We have gone through various, right? We are trying to write the relational algebra query to find the employee details who are working in the department of fund, right? So I hope you don't have any doubts here, right? Like this, we discussed almost 20 queries. Out of those 20 queries, the last two queries are like 19 and 20, which you cannot able to solve with the help of basic relational algebra operations, right? But the solution for all this is aggregate functions, right? Now in this class, we'll see various kind of aggregate functions. Okay, before this, for your practice, you can solve these questions. You need to retrieve the names of all employees which are in department 5 who work more than 10 hours per week on the IPL project. Can you solve this one? Right? Here we need to retrieve the names of the employees who are in department 5 who work more than 10 hours per week on the IPL project, meaning that the people who are working in the IPL project whose working hours are more than 10 hours, then I need to display all those names, right? So where these details are available, try to observe here. First, they have given the name of the project name as IPL, right? So and number of hours of the each and every project is available in works on table, right? But this works on table contains what data? Project number. There is no project name. If there is a project name, I can directly take the data from here works on table only. But project name is available in one location project, and the project hours are available in one location. So what is the common data between works on and project? Project number is there. So with the help of common project number, can I able to get the total number of hours of the project for IPL? Yes or no? Yes, I can do that. Right. So what I can do my first I will try to find out the project having project name contains the IPL. From which table I have to get? Project table. From this, can I able to get project number? Yes, I can get the project number, right? So if I get the project number, can I able to perform join operation with this with the works on table? Because there is a common data, right? So what I can do, I can simply take project number is equal to project number on which table? Works on table. Now I got the data where the data is completely related to IPL. Where data is completely related to IPL, right? Completely is related to IPL. But what is my requirement? They here you have to get the data which is having more than 10 hours, right? From this data, can I able to filter? Can I able to filter hours greater than 10? Yes or no? I filtered this data, and also the data should be belongs to one department number 5, right? Department number 5 and this data, is there any relation? Right? You can observe here there is a relation already. Department number 5, department number 5, right? So what you can do? Simple thing. Can you able to get the details of the employees from the department number 5? Yes or no? I can able to get, right? Try to observe. I am trying to get all the details of the employees who are working in department number 5. I got, right? From this I got what? All the employees who are working in IPL project which are more than 10 hours, right? Then can I able to perform Cartesian join operation between these two tables? Yes or no? What is the resultant is there? On this table you have ESSN, on this employee table you have SSN. Now the result is you have to produce once again project of first name comma last. That's it. This is the relational algebra query you have to write in order to get this data, right? Basically what I did, try to observe. You have to make it analyzation first, right? When you make analyzation, then only you can able to solve this question. See, not only this question, you can able to solve any kind of question, right? First thing is I would like to find out the IPL project. IPL project details are available in project table. From that, I need to combine with the works on table. That's why I made this one. I find out the details of the projects whose project name is IPL. So I am going to get all the details, and then I am going to combine this data with the works on table where the common condition is project number, right? Now this is what kind of join? Equijoin. Equijoin. Okay. Now from this data, I am going to filter what they have specifically, who works more than 10 hours. So I can able to filter, right? I can able to filter by selecting greater than 10, and then and also the data should be belongs to department number 5. So that's why from department number 5 I have got the data already, and I am going to combine these two by using SSN and employee SSN, and then finally I am going to project first name comma last name. Okay. Find second one. List the names of all employees who have a dependent with the same first name as themselves. Right? You know, employee table contains the employees and family table contains the dependents. Right? First, the question you have to understood. You have to list out the name of all employees who have a dependent with the same first name as themselves. What is the meaning of this one? So the employees who have the first name should be same as dependent name, and they have the dependency, right? If I am saying that JK is the first name and dependent is also JK, can I say that there is a dependency for JK or not? Yes. Simply what I can do, I can try to find out the equation between those two, right? What I can do, I am trying to find out the select operation. What I am trying to select is what you need to select. You need to select entire data, or you need to select only the columns. You need to select only column. Then you do we need to write like selection operation or projection operation? I am trying to go with the projection of first name comma last name, first name comma last name on the resultant data, right? But to get the resultant data, what you have to do, you have to combine employees table, family table. If I am going to combine employees table and family table, what you are going to get? You are simply performing join operation between employee table and family table. Then what you are going to get? You are going to get the employees with the dependence data. You are going to get the employees with the dependent data. But in addition to this, what they have specifically asked, name should be similar. Name should be similar, right? Can I directly like this? On employee table, I am going to check with the SSN is equal to employee SSN on family table. Is it correct up to here? Right? But in addition to this, what they have asked specifically, and first name should be dependent name. This is what they have asked. When both are matched and also their first name and their dependent name should be same, then only you are going to produce the first name and last name. That is what, right? Who have a dependent with the same first name as themselves, right? Next one, find the names of all employees who are directly supervised by Rohit Sharma, right? The question meaning is, here you have to produce all the names of the employees who are supervised by Rohit Sharma, right? Now can you able to get the Rohit Sharma ID number, Rohit Sharma SSN number? Yes. What you can do, select first name equal to Rohit and last name equal to Sharma from which table? Employee table. Employee table. Then what you are going to project? I am going to project SSN number. I am going to project SSN number, right? Now my question is, you have to identify the persons whose super SSN should be this SSN. That is the meaning of supervision, right? Then what I can do, I am going to simply perform theta join of SSN equal to, this should be, or ESSN. ESSN equal to this is, right? This should be again an employee table. Then you are going to produce the project of first name comma last. Is it okay, everyone? Right? See here, you have to think that first you have to find out the Rohit Sharma ID number. What is the Rohit Sharma ID number? 535. And then you have to find out all the employees whose super SSN should be 534. whose supervises should be the 534, right? That's the reason first I find out the 534, then you can able to find out the 534. That's why the result I am going to Cartesian product with the supersession. Then I can able to get Mithali Raj is one dependency and Kohli short is one dependency. This is the result you are going to get. Okay, this is I think 21, 22, 23. Okay, next one. For each project, list the project name and total hours per week spent on that project. Can you solve this? Can you tell? For each project, list the project name and the total number of hours per week spent on that project. Right? So right now you can't able to answer this one. Right? So the reason is you have to work with aggregate functions. Here they have specifically mentioned total hours per week on the particular project, right? But here if you observe the data, here project number 1, 531 working for how many hours? 12 hours. 536 project number 1 working for how many hours? 8 hours. Like this you have to identify all the project numbers, similar kind of projects, and you have to make it total sum. So that is what they have asked, right? But right up to now you haven't have gone through this concept, so you can just leave now. Okay. Retrieve the names of all employees who work on every project. Who work on every project. So blind and hard fast rule is when you are going to observe the terminology like all or on every project or on every something, you have to follow what symbol? Division. Division, right? So here the data is available in works on table. On works on table you have project number and hours. Works on our ESN, project number and hours. Total number of project numbers are available in which location? In the project table. These are the projects available, right? So from, like, if I am going to perform on works on table, if I am going to simply perform division with the project table, are you going to get the employee IDs who are working on all projects? Yes. Simply works on divide with project data, project of project number data. Then you are going to get all the employees who's working on all projects. Then you are going to simply Cartesian product with this ESSN equal to SSN in order to get the product of first name comma last name. Right? Next, retrieve the names of all employees who do not work on any project. Can you solve this? Who do not work on any project? What you can do? From works on table, you have the employees who working on all some at least one project. From this table, these are the employees. These are the employees. From this one, if you are going to subtract will what are the data that you are going to get is something like which are not working. Yes or no? Simply you can write the set difference operation. Here you can write set difference operation. Okay. Find the names and address of all employees who work on at least one project located in Kadapa. Located in Kadapa, but whose department has no location in Kadapa. Just read the question multiple times. They are trying to find out the employees who work on at least one project located in Kadapa. So meaning that in the first part what I can do, I would like to find out all the employees who working on the location called Kadapa. Project location called Kadapa, right? If you observe here on the project, we have a project location, right? Can this project location with this project location select project location equal to Kadapa from which table? Project table. Project table. I got the project numbers. I got these project numbers. Once I got the project numbers, can I able to get their IDs? Can I able to get their IDs or not? If I am going to combine with this one, I will get the IDs. Right? So how can I combine? By simply performing join operation on what? Project number equal to project number on project. Then you are going to get employee IDs also, meaning that the employees who are working on the Kadapa, you are going to get. Okay. From this Can I able to project only SSN? Yes. So what the resultant he contains? The employees who are working at the location Kadapa project. Kadapa project. This is what first half of the question. And what about the second half of the question? Whose department has no location in Kadapa? Right? Can we able to find out the employees whose department location is Kadapa? Right? So try to think from this department location. I am going to find out the department location Kadapa. Right? So simply think, select department location equal to Kadapa from department. With this, if I am going to if I am going to combine theta join with the employee table, what is going to happen? You are going to get all the employees whose departments are from Kadapa. Then can I able to project again SSN? Yes, right. Now if what you have to do, you have to simply perform set difference. What is the first part? The employees whose SSN are the project working on Kadapa location. Second part is the employees whose department located at Kadapa. Right? If I am going to simply remove this, you are going to get the answer or not? Okay. Next one, for each department, retrieve the department name and the average salary of all employees. Right? So you can't able to solve. Right? So this is what the operation related to aggregate functions. And again average. So it is not possible to solve this. Right? I hope you understood these all various kind of related queries. Okay. So in order to solve these queries, first you have to understand the concept of aggregate functions, right? So aggregate functions are meant for like as mathematical operation aggregate functions, which are used for to take set of values as input, and it is going to perform some grouping operation. It is going to produce single value as output. Right? So if I am saying that sum of set of values 1 comma 2 comma 3 comma 4, what is the resultant value? 10. Sum of 1 2 3 4, 10. Right? Something like average of 1 comma 2 comma 3 comma 4, 10 by 4, that is 2.5. Min of 1 comma 2 comma 3 comma 4, 1. Max of 1 comma 2 comma 3 comma 4, 4. Count of 1 comma 2 comma 3 comma 4, 4. Count means what? The number of elements which are present in the respective set. I can call it as count. Okay. Meaning that here sum means what? Which is going to perform the sum operation over the set of elements. Average means average operation over the set of elements. Min means trying to find out the minimum value from the set of elements. Max means trying to find out the set of max element from the set of elements. Count means total number of elements which are available in the set. Right? These are some of the aggregate functions which you can able to use. Right? So if you look into the basic syntax, that is attribute 1, attribute 2, attribute 3 and so on, followed by grouping operation of the functions. Function of f1 of some b1, f2 of b2 and so on the table called employee. On the table called, I can call it as a relation. Okay. So guys, here you can understand the meaning. I am trying to find out. I am trying to write some kind of query here. G represents grouping by. Right? Meaning that whatever the attribute that you are trying to define before the G, all those has to be worked with the grouping by operation. Right? Grouping by means what? If they have common characteristics, I am going to simply group them as a one entity. Right? All boys will be classified as one entity. All girls can be classified as one entity. All contract employees will be classified as one entity. All regular employees will be classified as one entity. All hourly based employees classified as one entity. Or else all CC people will be classified as one entity. All EC people will be classified as one entity. Like that is what the meaning of grouping. Right? If I am saying that, uh, gender gender is an attribute. Yes, right? So Before G, you have to perform grouping by operation. Meaning that I am trying to perform grouping operation over gender. If I am trying to perform grouping operation over gender, what you are going to get? Try to think this particular example. If I am trying to perform grouping operation over gender, how many classifications are you going to get? Two classifications you are going to get. So my result one contains two columns, two rows. What are those two rows? One is male, another one is female. One is male, another one is female, right? And in addition to the grouping, what result you need to classify? You would like to find out the total number of total number of male employees, total number of female employees, right? So total number count, how we are going to get? By using not sum. It should be count, right? Sum means different from count. Count of again gender. Again gender. This is available in which table? Employee table, right? This resultant query yields to the result. Yields to the result what? Male, female. How many males are there? 6. 6 males are there, amma. 2 females are there. And this particular column name is gender. Second column is count of gender. This is the new relation you are going to get. You are going to get, right? Fine. For example, I haven't written any kind of grouping attribute, right? I haven't written any kind of grouping attribute. G followed by count of gender on employee table. Then what is the resultant you are going to get? You are going to get total count, right? You are not going to perform any kind of grouping operation. So it will think all elements as one entity and it is going to group them. It is going to count them, right? So what is the total count you are going to get? Count of gender total 8. That is the meaning of this one, right? You can not only grouping single column, you can able to combine multiple columns also. Multiple columns also. Okay, fine. So the thing here is you can able to do like gender followed by department number. I am trying to perform grouping up. What is the meaning of this one? I am trying to perform the entire data grouping operation over gender as well as department number. And what I have to do? I am trying to perform count operation over the employee table, gender comma department number, right? So it is a kind of theoretical concept. You can write any manner like anything, but coming to SQL, you have to specifically write count of star, count of gender, like that we will do. Right? So now, what is the meaning of this one? How it will classify? Okay, can you expect the output first? One is gender, another one department number, another one is count of gender comma department number. This is the output can you expect, right? But in the resultant data, what you are going to do? See, if it is one particular column, it is going to classify elements into multiple ways. If it is two columns, here also it is going to classify them in unique ways, right? But the thing is here it is going to perform combination first. Combination first, right? If you observe this particular thing, it is trying to perform male and department number is 5. This is one column or not? One unique data. Male and 5. What about this one? Male and 5. Male and 5. Right? As they two related to single data, it is going to classify it as one entity. So now what about this relation? Male and 5 is 2. And female and 4 is 1 as of now. Male and 4 is 1 as of now. Male and female and 5 is 1 as of now. And male and 5 is 3. Male and 4 2. Male and 1, right? This is the data you are going to get when you are going to perform grouping operation over multiple columns. Okay, meaning that when you are trying to perform grouping operation over multiple columns data should be unique. If multiple columns data should be unique, then only it is going to combine the data. Okay. So once you perform grouping operation, you can able to perform your own operation. You can able to perform, like for example, I would like to perform grouping operation over gender followed by sum of salary on the employee table. What is the meaning of this one? I am trying to perform sum of operation over set of male employees, set of female employees, right? So male followed by female, and their total salary you are going to get individually. You are going to get. You are going to get it. Here it should be gender. Here it should be sum of salary. In other words, instead of getting like sum of salary, you can make the alternative for this as total salary. What is the meaning of as? JK as J Krishna, right? So the alias name for the given name, if you want to give, you can able to use the keyword called as keyword. So now here the column name is total underscore sum. So what is the sum of male? Around something like some around 1 lakh, some around 2 lakhs, like this, right? For example, the same query if I write like this, grouping of sum of salary of employee. What is the outcome of this one? Total salary, right? It is going to consider all the data as one unique entity, and it is going to produce some. It is going to produce some. That's it. So according to this data, you can expect it as 3 lakhs. 3 lakhs, right? For example, I am trying to find out gender G min of salary on employee table. What is the meaning of this one? I am trying to find out among the male employees minimum salary, and also I am trying to find out minimum salary of female employees, right? Because I have used a aggregate function called min, right? If I use max here, maximum salary of male employees, maximum salary of female employees. If I am not going to use this grouping attribute, minimum salary of all employees, maximum salary of all employees, right? So can you write the query for, right? You can observe here. You can observe for each department, retrieve the department name and average salary of all employees working in the department. Can you able to find out the average salary of all employees working in the department? How can you do that? First, can I able to perform all the employees grouping by department number? Then I am going to get the data related to each and every department. On the department, I am going to perform average operation. Average means AVG of salary from employee table. So what did I got? Department number followed by their average salary. But what they are asking specifically, department name. Then what you can do? On this data, you can able to simply perform data join department number equal to department number of department. Then I can able to project department name. I hope you understood. Okay, fine. Next, retrieve the average salary of all male employees. What is the query you can able to write for 29? Retrieve average salary of all male employees. What is the answer? Can I write this one? Can I write this one? Yes, I can write. But is this the final query? No, because it contains female also. But they are specifically asking only male. At the time, what I can do on this data, I can able to select once again male. I can select gender equal to male, right? Or else, what you can do? First, you can able to perform select gender equal to male on employee table. On this, you can able to perform aggregation, right? What you can do? Simply sum of salary. Then there is no meaning of grouping also here. Okay, so like this you can able to write. What about this one? Retrieve average salary of all employees. In here it should be average. Average salary of all employees means no need to perform any filter, just write average of salary of employee table, that's it. Okay, fine. Right, try to come up with this question. Display the total salaries of all employees. Then what is you have to do? G sum of salary on employee table, that's it. Display the least salary amount among all the employees. G minimum of salary on employee, that's it. Okay, right. Try to take this question, this one, right. So here the given data contains the product name, quantity and their respective unique identification numbers, right. Assume that this table name is fruits, table name is fruits, right. I want to find out, I want to find the total quantity of each and every product, the total quantity of each and every product. How can you write the query? Total quantity of each and every product, meaning that my result should be apples 200, oranges 220, banana 600. That is my result. What we can do? Can you able to perform grouping by operation? Yes, right. So simply product name group defines sum of sum of quantity, sum of quantity on fruits. That's it. That's it, right? For example, my question is find out total fruits. Then what you can do? Simply we are going to perform G sum of quantity, sum of quantity. Right? For example, average. If they are asking for average, in place of this one, you can able to simply perform average operation. Right? For example, if they are asking for count of each and every item, count of each and every item, then what you can do? Product name group count of quantity or count of product name, whatever it may be, you can write. For example, tell me the result of this query. I am trying to write the query itself. You can tell the result. Product name, comma, quantity, grouping of count of something star on fruits. What is the outcome are you going to expect? Obviously, you are going to get the product name, quantity, count of star as I am making it as count. You are going to get 3 columns, that is for sure. But how many rows are you going to get? So can I write the first row as apples followed by 100 followed by 1 as a first line execution. I have written like this count. Oranges, can I write one more row, oranges 120 as of 1, apples 100. What will happen? This will replace incremented by 1, that is 2, and bananas 300, bananas 300 1, and oranges 100. Can I able to add here? No. You have to take one more. Oranges 100 1 and bananas 300. So total how many rows are you going to get? 4. This is important to me. So this is what I can call as grouping by multiple columns. Multiple columns. Okay. Fine. Okay. So try to think they have given certain set of data, country, state, city, friend name. So just tell me the answer. How many rows are you going to get when I am trying to perform grouping by operation over country, state, city, grouping by of, count of star over, like for example, world map. How many number of rows are you going to get? Hmm? I think you won't get all. Try to observe India, Andhra Pradesh, Kadapa, India, Andhra Pradesh, Kadapa. Right? These will be considered as 2. And I think remaining all are unique. So we are going to get this number of columns: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So total 13 rows you are going to get. You are going to get, right? But if you are going to do like this, country, comma state, group by count of star on world map. Now how many rows are you going to get? Same? No, right? If you observe here, Argentina Mendoza will contains 2 now, act as a 1, and I think USA is different, Argentina is different, this Brazil is also different, Venezuela different, all this different, right? Now how many rows are you going to get? You are going to get 12 rows, sure, 12 rows, right? If you are going to perform like this, you are going to perform grouping by operation over country, grouping by count of star over world map. Now how many rows are you going to get? These three will be as 1, these 3 as 3, 8. Okay, so I thought your answer is correct. So that is 8 rows. Okay. For example, if you are going to have nothing group by, I am trying to perform count of star over world map. Now, so there is no operation of grouping itself. So then you are going to get all the count. You are going to get all the count. What is all the count? I think 14. You are going to get 14 rows. Okay, that is the meaning of aggregate operations. If you observe here, I think one more question is there. For each project, list the project name, total hours per week spent on that project. Right? We need to produce the project name. Before that, you have to find out the total hours working on that project. Right? What are the total hours are available in the works on table? In works on table, can we able to apply group by operation? So total hours working, total hours are you going to get or not? Yes. Right? I am going to perform project number group by sum of hours on works on relation. Now what you are going to get? You are going to get total hours are taking for each and every project, right? Now, but you required what? Project name. Project name is available in which location? Project table. So you can able to simply perform theta join project number equal to p number on project table. Then you are going to get this data. Then you are going to simply project name. This is the query for 24th one. I hope you understood, right? Okay, fine. So is it clear for everyone? Okay, Namma? Okay. Next, we'll go with one more kind of database. So far we have worked with the company database, right? Now we'll go with one more kind of database, sales database. Here, what is this one? Schema. Sales database schema. So it contains 3 tables. One is sales table, reserves table, and boards table. Sales table contains 4 columns. Among those, SID is the primary key, and reserves contains 3 columns. Among those, SID is foreign key, BID is foreign key, and day is normal data, and if you are going to combine this SID and BID, it may yield to primary key also, right? You can observe it as M2N relation, where day is the relationship attribute. Very good, relationship attribute. That's why you got it as a separate table. Reserves is a relationship. Okay, and if you observe in boards table, BID, bname and color are the three attributes. Among those, BID is the primary key. Okay, this is the schema they have given, and you need to write the relational algebra queries for all this. Okay, write down first one. Find the names of the sailors who have reserved boat 103. Who have reserved boat number 103. See, boat reservation details, reservation details available in which location? Reserve table. Reserve table. But they are asking for here names. Names are available in which location? Sailors. So compulsory we need to perform first join. Join. On what basis you have to join? You have to join based upon their common data, right? On SID you have to combine, but you need to first find out the people who reserved the boat number 103, right? Then what you can do, I am going to first write select BID equal to 103, on which table? Reserves table. Now it contains all the data including SID, right? On this I am going to perform join operation. From right side you are going to get what? SID, and left side also you are going to get SID. If you are going to use here sailors table, right? So in some textbooks they will so to differentiate they will write as sailors dot SID, and this SID as reserves dot SID. See, as this is a theoretical concept, you can write in any order. There is no problem. The way your understanding should be clear, right? Sailors dot SID is equal to reserves dot SID. SID. Then you are going to get all the data who reserves the boat 103. From that, I am going to project yes. That's it. This is the relative like relational algebra query for the first one. Okay. Next, second one. Find the names of sailors who have reserved red boat. Who have reserved red boat, right? Here observe red boat. Boat color is available which location? Boat's location. Boat's location. But they are asking finally what? Names of the sailor, right? So if I want to find out the names of the sailors, first they have to find out the IDs. IDs are linked with boat IDs. Boat IDs are linked with colors. So you have to combine finally three things, right? So you can simply write first I am going to select boat color. See, it should be color only, not boat color. It should be color equal to red from boats table, and then I am going to join with what data? BID, and here BID. This should be is equal to, right? Instead of writing like this, can I use star operator here? Can I use star operator? Because both contains the BID. Now it should be results. Results. Now I am going to perform once again star operation over sailors. No need to perform like SID equal to SID. You can just simply write sailors. And that you are going to simply write project of yes. That's it. This is the respective query for the second one. Find the colors of boats reserved by INS. What is INS here? INS is boat name. INS is a boat name, right? So find the colors of boats reserved by INS. So do we think that INS is the name of the sailor? Yes, ma. So we can think, right? We don't have any clarity here, right? As they are saying that reserved word, I can think it as INS as a sailor only. If I am thinking that, so INS is a S, INS is the S name. They are asking for colors of the boards, right? So meaning that they are trying to right now getting from top to bottom. First you are going to find out all the people whose name is INS from which table? Silas table. From that, I am going to perform operation with reserves so that SID matched. So I am going to get all the SIDs of the people who have INS name, and also I am going to get BID who have reserved INS. Then I am going to perform natural join with again with boats. Then I am going to get all the data who are having S name as INS. Now from that I am going to get colors. Project of color. Is it okay for everyone? Next one, fourth one. Find the names of sailors who have reserved at least one boat. At least one boat, how we are going to get? Can you first tell what is the need of going with aggregation? Right? They are asking for like, if they are asking for, okay, aggregation also one solution, but is some long procedure. Instead of that, trying to find out the people who haven't reserved any boat. Can you able to find out? Right? Okay, fine. In another way, you are need to find out the names of the sailors who have reserved at least one boat. At least one boat. Meaning that if the ID number is available in reserve table, what are the meaning of this one? They have at least one boat. I need to produce their name. What you can do simply? Project of S name on what data? Sailors natural join with reserves. That's it. So you are going to get the fourth query. Next, what about the fifth one? Find the names of sailors who have reserved either a red or green boat. So there you have to think about colors right now. So can you write like this? Select color equal to red or color equal to green on board table. Okay, fine. Then I am going to perform compulsory name. If you want to get the names, I have to go with all. Boards I have reserves I have to do, and then I have to do sailors. From that I am going to perform projection of S name. Projection of S name. Can you do it? Yes. Next one, think about this one. Find the names of sailors who have reserved red and green boat. Can I write and operation? Right. This is where you are going to get wrong. If I write here and, what will happen? Just think about it. What is the meaning of and? At the same time, it has to satisfy both. When both are true, then only our result is true. Right? What about the R operation? When any one of the true is true, then the result is true. That's it. So in terms of R operation, when in the table it is going to check for color equal red, it is going to put that as the output. Color equal green, it is going to put that as a relation. I hope you understood, right? But when you go for color equal red and color equal to green, what are the meaning of this one? Is there any tuple at the same time which is going to satisfy both color as red and green? Yes, sir. No, it is not possible, right? So that the way that you are writing is incorrect. So meaning that in place of this R, if you are going to write and, that is incorrect query. Because the simple thing, true and true is true, but there is no such kind of board which is having both red and green color at the same time. Right? So then you have to find out the another solution. What is that? Intersection operation. So you are going to find out all the boards having the color red from the boards table, and you are going to perform natural join on reserves, natural join on sailors. You are going to project all the SIDs, and then you are going to find out color equal to green from boards table, natural join on reserves, natural join on sailors, and then I am going to project their SIDs. Their SIDs, right? Now we got the data in such a way that who have reserved red board, who have reserved green board. But the question is, who have reserved both red and green? Can I able to perform intersection operation between these two? Yes. So you are going to get the common data. So this is important. This haven't covered this kind of thing in company database. That's why I have gone to this database also. Right. Next one, find the names of sailors who have at least two boats. This is also somewhat different. Find the names of the sailors who have at least two boats. Right. So what is the meaning of this one? Earlier we are asking the question like at least one boat, meaning that if the data is available in reservation table, I can say that he has reserved something, so I can consider. But now the question is, even it is in the reservation table, they have to be at least two reservations. How can you do that? Any solution for it? If it is in SQL, I can write it. I can write the simple query. Okay, but in relational algebra, you have to follow certain different procedure that we'll look into the next class. Okay, fine. So meanwhile, you can also check the solution for it. Next one, find the SIDs of sailors with age over 20 and who have not reserved a red boat. What is the meaning of this one? Can the query comprise of two questions? One is whose age is over 20. Can I able to write one query for with age over 20? We can able to simply select age greater than 20 from sailors table and who have reserved a red boat. Can you write another query for who have reserved red boat? Yes or no? From this you are going to get SIDs. From this you are going to get SID. If you are going to perform set difference, what is the meaning of this one? Who have not reserved red boat and which age is greater than 20. Right? You can observe this one as not. Next, find the names of sailors who reserved all boats. All means what? Division operation simply, right? Who reserved all boats? All boats, right? Meaning that by reserved by boats of boat IDs. Boats of boat IDs. Then you are going to get what? SIDs as well as day. SIDs as well as day for the persons who reserved all the boats. Reserved all the boats, right? From that, you are going to simply perform theta join, where SID equal to SID on sailors. Then you are going to simply project the data. This is the query for ninth one. Is it okay? When you are going to observe all, you can simply say that it is division operation. Right? You can go through the earlier video where why you are going to go with the division operation. Right there, while writing, I have explained clearly. You have to take out first denominator. Denominator must and should have all possible values from the numerator. Next, find the names of sailors who have reserved all boats called navy. The same with extension. What is that? You have to add one more condition and color equal to and boat name equal to navy. That's it. Boat name equal to navy, right? Product of S name sailors. I can make natural join reserves by boat of BID, boat of BID, and boat name equal to, that's it. This is the query for 10th. Okay. So these are some of the questions which we may come across the sales database. Many questions are possible. You can able to practice it. This is for today's class, Amma. If you have any doubts, you can ask.